Welcome to Sundar's lecture. This is lecture number 83, and in this lecture we are going to see energy stored in mutually coupled coils, right? So what are all the topics we have seen in the previous class? See, we have started with the new topic, that is basics of coupled coils. In basics of coupled coils, maybe we have gone for a dot convolution, right? So before that we have seen what is self-inductance and mutual inductance, and those kind of things, and what is dot convolution and how we represent the dot convolution in a mutually coupled coils, right? What is self inductance and mutual inductance, and how we need to write the expressions if coils are connected in series, and that to aiding, and the coils are connected in series when it is opposing, and what is the L equivalent, right? What is the inductance, equivalent inductance in the coils, right? And then we gone for parallel aiding, right? In parallel aiding, we have seen one topic, that is aiding, and we have not seen the parallel opposing. I have told you to do by yourself, and you will get this equivalent inductance. That is the only one change will come, that this one will be plus in this expression if it is opposing, parallelly opposing. If it is parallelly aiding, then you will get the denominator to be L1 plus L2 minus 2m. That is the whole idea. And in today's class, we will see what is the energy stored in mutually coupled coil. See, this is a coupled coil, coil 1, and I have represented it with A and B terminals, and this is the coil B, and we have the terminals to be C and D. See, this one will have L1 and this one will have L2. These kind of things we already know. And what is the thing we need to find if it is if we need to find what is the value of energy stored? You need to know what is the power, right? Instantaneous power. We need to find instantaneous power, right? Instantaneous power. What is the instantaneous power of these two coils? It will be P will be is equal to, maybe P of T will be is equal to PAB, that is for these two terminals, and then plus PCD. I have to find these two values, right? So PAB will be is equal to VAB into I1, right? This current, that is the voltage and the value of current, and then plus this value will be VCD into the current of I2, right? This is, I need to find the values, right? Now, how will you find the value of VAB? We know it is very simple. VAB or V1, anything, it may be same, right? Between A and B, I have written it as V1. Between C and D, I have written it as V2. So VAB, how will you write the VAB value? And I will do it again because it will help you to understand how things are going. So this one, we need to write the self-induced EMF as well as the mutually induced EMF, right? So self-induced EMF, the current is coming, whatever it may be, you don't need to see for the sign. Maybe it has to be plus, right? So what is the value? So the value will be I1 into this value, L into L1, this value, self-inductance, into dI1 by dt. dI1, I'm not putting of t, you defaultly understand because it will be congested, right? So this is the self-induced EMF plus, see here, I need to see the sign for mutual induced EMF, because see, this current is coming towards or entering into the dot, and also the second coil current is also entering through dot, right? This two coils has a mutual inductance, so you have to write the mutually induced EMF. That those kind of things we have seen in the previous class. See, this also enters through dot, this current also enters through dot. So what I have to write here, I have to put plus M into di2 by dt, di2 by dt. And if I am going for the other thing, this is for VAB, and if I am going for VCD, that is also very simple. That's all right. I have written the values, self-induced EMF and mutually induced EMF. And for VCD, you straight away put L2, that is self-induced EMF in the coil number 2, that is di2 divided by dt, and then plus, because this coil current is entering through dot, this coil current is also entering through dot. So it will be M into di, second coil's current, first coil current, di1 by dt. So this is the value, right? Now I can substitute in the expression as PAB will be is equal to, maybe I will directly substitute. Why I need to substitute here? So P of T will be is equal to, what is the value? It is VAB into I. What is VAB? It is this value, right? So L1 into di1 by dt, di1 by dt plus m into di2 divided by dt multiplication of I1, this equation, and then plus VCD, that is L2 into di2 by dt plus m into di1 by dt multiplication of I2, right? This value. So I have substituted this one, right? So if I am writing energy stored, how will you write? So this value dW will be is equal to P of T into dt, small time I am taking, and for W I am taking the derivative. And what will you get here? So I will write, which is equal to dt. I have to multiply both terms with the dt, right? So if I multiply that one, so straight away I will write the expression. I will multiply dt. So L1 I1, this multiplication into di1 by dt. So I am multiplying with the dt, so it will get into dt. So plus m into I1, and this value di2 by dt multiplication of dt. This is the first term, plus for the second term also L2, this I2 will come inside. So it will be I2 and di2 by dt multiplication of, I am multiplying with the dt, right? So it will be like this, and then plus m into m into I2 will come, m into I2 di1 by dt multiplication of dt, and every dt's now will be cancelled out, right? Cancelled out. So finally what you will get as dw will be is equal to L1 I1 di1, that is the first term, and plus m into I1 di2, that is the second term, plus L2 I2 d this one di, this is the 2 di2, that will come here, and then plus m into I2 di1. So if you need to take the integration, right? If you take integration on both sides, this will become now w, right? If it is so, then what we will do? So before that, I will rewrite this one. Anyhow, I try to rewrite, because one thing will come that will help you. This one L1 di1 di1 L1 I1 plus L2 I2 di2 will be there, and then see this one m, you take commonly m in both terms, what will you get? It is I1 di2 plus I2 di1. What is this one? This is nothing but UV formula, right? This is nothing but UV. Differentiation of UV. First term kept as it is and differentiating the second term. Second term kept as it is and differentiating the first term. It is a UV formula, right? So we can rewrite. See, I have just taken it to the next page. And now you integrate on both sides. Integration dw will be is equal to, and this one from 0 to I. For example, if you are going for the steady state understanding, at steady state, the current I will reach to the maximum point, right? So what we will do, we will take from 0 to I1. Maybe the final value of the current will be I1. Maybe in some books they will put capital letter I1 to differentiate the normal I1 and the final steady state I1. Maybe I will take it as same one because there is no difference. Okay, anyhow, see now if I integrate, so L1 will be outside, right? And the integration of 0 to I1, 0 to I1, I1 into DI1, right? This one. So in some books they will take this as the capital letter I1. Try to understand. That is the final, to differentiate the final steady state current. But I will take as it is. No problem. See, I assume that the final steady state is as the small letter I1. Right, this one plus if I integrate this one, this is L2 integration of 0 to I2 into I2 DI2 with respect to this one. See this one now plus m into integration of what is this value? What is this value? D by dt of uv. What will you get here? U dv plus v du. That is what we are getting here. That is what we are getting here, right? Try to understand the same term, same term. Try to relate these two. What you will get? You will get differentiation of I1 and I2 and I2. This will be 0 to I1, I2, the final steady state, because this is like this, right? So this has a constant value. This has a constant value. So if I integrate this one, what I will get finally? So finally I will get W will be is equal to this first term will get half L1 I1 square, half Li square plus if you integrate this one will be half L2 I2 square and then plus this value you will get M into I1 I2. So this is the final energy stored in the inductor. Yeah, energy stored in the coupled coils, total energy. Try to understand. And you see, I have already told you in some books they will give this as capital letter I1 to differentiate the final steady state, right? Because we are getting the final value as a constant value, right? How constant values will come if current is changing? No, it is not possible. Anyhow, you assume that this I1, this I2 are the final value of the current, right? Right. This is the energy stored in the coupled coils, right? Now what we will do, we try to find what is the coefficient of coupling. We have not touched that topic till now. We know what is self-induced EMF and mutual induced EMF, and we need to know what is the coefficient of coupling. See, we will see that now. Right, see this one, this is now coefficient of coupling. See, this one we know already. See, we have excited this coil. There are two coils, right? So, we have excited this coil and there is a flux has been generated in the core and we have connected a second coil. See, if we are exciting this coil too, this will produce the magnetic flux line and we will have a mutual inductance between these two coils. I have not represented that one, anyhow we will have that too. So mutual inductance will be also there. So mutual inductance will be there. See, what is the problem here? Will all the flux generated in the coil 1 will link to the coil 2 if one is excited, and And also, if coil 2 is excited, will all the flux generated in the coil number 1 will link to the coil 2? No, it is not possible. Why? Because there will be some leakage fluxes. Leakage fluxes will be there in the core, or it will be passed through the air between these places. See, we need to know how much of flux lines that have been generated in one coil linked to the other coil. The ratio between these two, we will take it to be coefficient of coupling, right? The value of the coefficient of coupling. See, we generally represent this in letter K, and generally this value will be between 0 and 1, right? So we try to do that now. For example, what is the total flux here? See, the total flux pi T1, maybe if I take it so, pi T1 will be is equal to pi M1, that is flux that passed through the core, and some of the fluxes that has been lost here. So that will be pi L1. Right? Can you understand? So now if I go for L1, what is the formula for L1? It is N into pi N1 into pi T1 divided by I1, pi T1. Because first coil, it has self inductance, right? This self inductance will be the total flux generated in the coil number 1. So that is the whole idea, right? So I have written like this now. So the next point, what is the pi L1 now? What will be the pi L1? This leakage flux. See, this leakage flux will be maybe 5 to 10 percentage of the total flux generated in the coil number 1. So what I will do now, I will just write K1 bar pi T1. Why? Because this value will be this value will be 5 percentage to 10 percentage, right? 5 percentage to 10 percentage, maybe, right? So this value. So I have written this one, and if I am going for pi L2, if the second in this coil, if I excite this coil, maybe you try to understand, and I am writing it to be K2 bar pi T2, pi T2, right? This one. Now, if I'm writing what is the value of L2, L2 will be is equal to N2 pi T2 divided by I2. See, I have not shown you. I have not shown you. This is coil number 2. This is plus minus V2. If I exit this coil also, I will get the self-inductance, right? So now, what is the value of mutual inductance? That is the whole idea. See, mutual inductance M will be is equal to N1 is this for example, if I am writing it for M12, that means the see, if I am writing it for the first coil, N1 and then pi M2, that is the second, because of the second coil, divided by I2, because second coil will be excited, and thus will be is equal to the same value. That means 1 minute. It is okay, fine. So that means what is the problem here? See, this will be is equal to M21 will be is equal to N2 pi M1 divided by I1. See, I am writing pi M1, pi M2. Try to understand. If I exit this coil separately, and if I further simplify this value will be is equal to N1, N2 divided by S. So, we have commonly written M is the value that is equal to M21, and that is equal to M12, right? So now what I can do, I can just equate these two equations. So N1, what is the value of pi M1, pi M2? See, I will take from here, maybe this also can be written as pi T2 can be written as what? Pi M2 plus pi L2. So if I take from this expression, so what I can write now, instead of, maybe I will write it down, pi M2 divided by I2, and then plus, sorry, not plus, equal to N2 pi M1 divided by I1 divided by I1 will be is equal to, commonly I will take M. Now you substitute, maybe I will write M here. M will be is equal to N1. This value pi M2 can be written as, you can replace, right? So pi M2 can be written as what? Pi T2 minus pi L2, right? Whole divided by I1, and then this will be is equal to N2, and I can write pi M1 in terms of pi T1, right? So pi T1 minus pi L1 divided by I1. This is I2, right? This is I2, and this will be now I1. See, now what I can do, I can write M will be is equal to N1 into this pi L2 can be written as what? Like this, right? So pi T2 is already there, minus this pi L2 can be written as K2 bar into pi T2. So K2 bar into pi T2, right? Right, divided by I2 is already there, and then this will be is equal to N2 divided by I1. Instead of this pi T1 I can keep as it is, minus pi L1 can be written as what? K1 bar pi T1, this one. So now I can take this pi T2 commonly outside, right? That is also possible. So if I do so, M can be written as N1 pi T2 divided by I2 divided by I2. What this will be now? This will be now 1 minus K2 bar. 1 minus K2 bar, and this will be is equal to, and if I take this one, N2 pi T1 divided by I1, and this will be 1 minus K1 bar. This is the equation. This is the equation. What I will do now, this is also M, this is also M. Now I will multiply these two. I can do like that, right? So I will take it to the next page. So if I multiply these two expressions, so what you will get? It is M square will be is equal to N1 pi T2 divided by I1 multiplication of N2 pi T1 divided by this is I2 divided by I1 multiplication of 1 minus K2 bar into 1 minus K1 bar, right? It is simple. Now if you further simplify this, I can write like N1 pi T1 divided by I1, this value, multiplication, right? This value, this value, this value, multiplication of N2, this value, and pi T2 divided by what? I2. This is 1 minus K. This is a constant, right? This is a constant. That is what I have told you, 5 to 10%, maybe 0.1, 0.05 to 0.1. So if it is so, then I can write this one into K1 into K2. The whole value I have multiplied K1, K2, right? That is also possible, and this is also constant, right? So this one and this multiplication of constant will give you a constant. See, I will further simplify. So M square will be is equal to, what is this one? What is this one? This is what we have written here. It is L1, and what is L2? This value. This is L1, this is L2, right? So this value is L1, this value is L2. So constant multiplication of constant, it will be constant square. I am taking it to be K, commonly K. So now if I bring this K square one side, K square will be is equal to M square divided by L1 and L2. So finally what I can write, if I write the K value, I will write here separately. K will be is equal to, if I bring square root to this side, so this square will be cancelled out. M divided by square root of square root of L1 and L2. So this is the value of K. This is the value of K. And what is this one? This one, which is nothing but coefficient of coefficient of coupling. Coefficient of coupling. So you try to understand, for a coil, we have already seen this one. For a coil, M mutually induced EMF is a constant one, right? Is a constant one. What is that one? M will be is equal to N1 N2 divided by S. It is a constant, and we know the for a particular coil, L1 is also a constant value. What is that one? So L1 will be is equal to N1 square divided by S, and for a coil, this value L2 is also a constant. Is also a constant. What is that value? L2 will be is equal to N2 divided by S. We know these three values. So, if all these values are constant, then for a coil, this value K will be also a constant, and that K will be is equal to M divided by square root of L1 and L2. Right? Am I right or wrong? See, this value, which means this N1 and N2 by S, is only valid when the when there is no leakage fluxes. When there is no leakage fluxes. Why? Because we have learnt like that. See, here in the derivation of mutual inductance, what we have taken, this one, we have derived this expression, right? How we have taken this expression? See, we have taken pi m1, total flux that has been generated. We have taken that value as the in L equation 2, L1 also we have taken it what? We have taken the same value. Try to understand. That one is very clear. See, this particular value, I will tell you, this one is only valid when all the fluxes in the coil 1 linked to the coil 2. Try to understand. Try to understand, right? Because why I have told you, see, this is constant, this constant, so this value will be a constant. So straight away you can just specify for a coil the value of K to be a constant value. That is why I try to tell you, right? Right. So what are all the topics we have seen today? We have taken the topic with the energy stored in mutually coupled coils, and we have derived it to be half Li square plus half of L1 I1 square of L2 I2 square and M into I1 I2. This is the energy stored. And we have gone for coefficient of coupling. And what is the formula for coefficient of coupling? It is M divided by square root of L1 and L2. And always K value lies between 0 to 1. 0 to 1. And if it is 1, then what happens? All the flux lines in the coil number 1 linked to the coil number 2, or coil number 2 linked to the coil number 1. That is the whole idea, right? We will see in the next class. Thank you.